Now we're going to define the loads. What are the loads? The loads are the forces acting on the structure. So the loads are the forces acting on the structure. So they are the external forces acting on the structure. And the main function of the structure then is to sustain the loads, is to resist the loads safely without any damage to the structure or to any members of the structure. Okay, the loads are defined or could be classified into concentrated loads and uniformly distributed loads. They could be uniformly distributed or non-uniformly distributed. So the loads are mainly classified into mainly two categories according to the way they are applied on the structure. Number one is the concentrated load. It's a point load. It's a load acting on one point or a very infinitesimal area of the building or of the structural element. So the concentrated load is in kilonewtons or newtons or tons or pounds, depending on the unit system. So if we're talking about the metric system, the force is in metric tons or in kilonewtons. So this is a concentrated load. The concentrated load could be vertical, horizontal, or inclined. Okay, if it is inclined on an angle alpha to the horizontal, then we resolve it into two different components, horizontal component and a vertical one. So the P on inclination of alpha to the horizontal will be resolved into P cosine alpha in the x direction and P sine alpha in the y direction. And the force could be acting inwards on the beam or outwards, which could be pushing down the element or pulling up the element. Okay, so this is a concentrated category, concentrated load category. The second category is a distributed load. So distributed load could be uniformly distributed or non-uniformly distributed, which is the load, distribution of the load means the load is being distributed on a certain area, non-infinitesimal on a bigger area of the building or of the structural element. Okay. So the uniformly distributed is W, uniform capacity, constant capacity, let's say ton per meter, over distributed over a length L. Okay, so the load is distributed, so it has to have two values for point of action. So the two values, the value W ton per meter distributed over length L and acting downwards or acting pushing down the element. Okay. And the default is to have the loads down. So if somebody forgot the arrows, they point down to the loads or define that the loads are going down. So the default is the loads are going down unless otherwise mentioned. Okay. Um, so for every distributed loads, we have to know the resultant of the load and the point of action of the load and the direction. Okay, if it is down or not, if it is going up or down. Okay, so if there is a distributed load, uniformly distributed load, W ton per meter over length L, this is equivalent to WL, which is the total load, W multiplied by L, which is the total load acting at center line or acting at the midpoint of the load. Okay, or at a point which is L over 2 from either side of the distribution. Okay. One example, there is a beam and supported in two columns. Structural system is one line, so on one support, hinge on one side, roller on one side, and W ton per meter equals own weight of the beam. So this is one example. This is the vertical one. It could be inclined one, like the loads on the stairs. Okay, the loads are acting on the vertical, the inclined portion of the stair, but they are acting vertically downwards. So W ton per meter, they are actually summed up over the inclined portion, which is L dash. So the total load is WL dash acting over L over 2 dash half of the inclined portion or half of the horizontal portion. So for the horizontal portion, it divides it into two portions, L over 2 and L over 2. And for the inclined one, the resultant is acting halfway. So the load is L dash over 2 from one end of the load, L dash over 2 from the other end. Okay. Again, the representation, if there is a beam and two columns on each side, so the representation, structural representation, is having one inclined line which represents the beam with two supports and double equal all weight of the beam, ton per meter. The vertical load is going downwards and distributed along the line. Okay. One example of this is could be the own weight of the building. But if the load is vertical, it's the own weight of the building. If the load is perpendicular to the inclined surface, so it is wind loading. One example is wind loading. It's acting perpendicular to the inclined surface, not vertically down. Okay, so the load is acting perpendicular to the current surface. One example is wind. Okay, so W ton per meter when load on the inclined portion, hinge at the one end and roller at the other end, and the load is perpendicular to the element, so it means like it's wind loading. It's not vertical load, it's not weight, it's not weight, it's wind loading or earthquake weight loading. Another example, okay. The load could be actually, I mean, inclined, like on the inclined surface, but it could be actually summed up over the horizontal portion. So it could be summed up over L. So W ton over meter summed up over L. Okay. This could be the live loading stairs or weight of persons on the stairs. Okay. So for wind loading, could be also horizontal portion and could be inclined perpendicular to the stairs or horizontal. So WH acting on the stair, acting on the vertical height, H over the center line over height H. The resultant acts at half of the height, H over 2 from the top, H over 2 from the bottom. So this is the second one, the uniformly distributed load, and we've given some examples. The other one of the uniform load is non-uniformly distributed load, means like it's like triangular or trapezoidal. So triangular loading, for example, you have one load at zero intensity at one end and then double ton per meter at the other end. And it's distributed over length L. Okay, same thing like for the other distributed load, we have to know in order to fully define the load and to work with it and to solve the problem with this loading, we have to know the resultant of the load, which is the area under the triangle, the point of action, which is the point of action of the resultant, which is the CG of the triangle, which is one third from the base, and then that direction in this case vertical down. Okay, so this one in this case W acting over L from 0 to W centimeter. So the resultant is half WL. It's acting on one third of the length measured from the base and two thirds from the apex or from the head. Okay. If it is trapezoidal, then there is W2 ton per meter, smaller intensity, W1 ton per meter. So this one could be divided into two rectangular portion at W2 ton per meter intensity and triangular starting from 0 to W1 minus W2. And there are two results, P1 acting at halfway and then P2 acting one third from the base. So P1 equals W2L and P2 equals half W1 minus W2, which is base of the triangle multiplied by L. Okay, or could be divided into two triangles. One triangle W2 to 0, the other one 0 to W1. Two triangles added together. So when acting at L over one third from the other base, and the bigger one is acting at one third from the big base. So P1 equals half W1L, P2 equals half W2L. Okay. Now we're done with the laws, or when we're going to take a break. Thank you.